Okay, so we'll go ahead and get started then. So of course, as you can see, we are working on uh, chapter 3 today. So we'll start with our section 3.1. So we have talked about, the quadratic equations in chapter 2. We started chapter 2 by talking about quadratic equations. So now we're just getting into the discussion with them as quadratic functions. So, in chapter 2, we looked at these equations as, ax squared plus bx plus c equal to 0. And in this chapter, we're setting it equal to y, basically. So for your f of x, you can either have f of x or you can have y equal to ax squared plus bx plus c. And again, you will see we have the same restriction on our a value. We don't want the a to be 0 so that our x squared term will not disappear. And then, of course, in section 2.3, we also looked at the transformation equation of our quadratic function. So remember, a value was where you either had a stretch or a shrink happening to the shape of the graph. If there was a negative on the a, that basically meant you would have a reflection. The h value was where our graph was moving to the right or left, depending on, again, if it was a positive or a negative number. And k was making our graph move up and down. So those properties are still going to stay the same. None of those things are changing. So the first part we're actually looking at is how to convert from one form to the other. So right now we want to see, if our equation is given to us in the standard form, how can we convert it to the transformation form? So again, if you guys have seen the video lecture, then that should be one of the first examples that we start out talking with. But this is the example we're going to be looking at. And so let's walk through the steps, take a look at how you can rewrite this equation from the standard form into the transformation. So remember, the transformation form is where we will be rewriting this in the y equals a parentheses x minus h squared plus k. So the first thing we're actually going to do is basically you have to use completing the square as your method over here for rewriting this from the standard to the transformation form. So remember, guys, for completing the square, the coefficient on our x squared variable has to be +1. And right now, in front of the x squared, we have a -3. So we need to find a way to get rid of the -3. Now, when we talked about completing the square, that was in chapter 1 and in chapter 2. So both chapters, we talked about how we could use completing the square. The one problem we have over here is we cannot do anything on the left-hand side. So you see where we have the y equals. You cannot add, subtract, multiply, or divide numbers on the side where you have the y variable. So all the calculations that we are going to be doing, all of them have to happen on the right-hand side. So normally what we would have done if we wanted to get rid of that -3 from our x squared, we would have just divided the entire equation by -3. So since we're not able to use division because I cannot do anything on the left-hand side, what we are going to use is factoring. So what we need to do is take the -3 outside, factor it out of our first term. So you're going to have just the x squared left behind from that first term. And we also have to factor out that -3 from our middle term, which is the +x. So you can see your +x, just has a coefficient of basically +1 over here. So, -3 will not be factored out of that. So what we do actually is, since we cannot factor out a -3 from this middle term, you just end up dividing it by -3. So close the parentheses, and we're only going to be doing this with the first two terms. That -1 at the end is going to stay as it is because we're only working with the first term and the middle term when we're talking about completing the square. So one thing to remember is if I were to go back and multiply this -3 into my x squared, I should get back to my first term. When I multiply the -3 with my second term, I should get back to my original second term. So, we're not changing our calculation. We're just rewriting the equation over here. So you will see -3x squared gives us the first term, -3 multiplied with the x over -3. Basically, those -3's will cancel out, ending up giving us the middle term, okay? So that's kind of what we are doing over here. So bring that -3 outside. And once we have accomplished that, now we are ready to do completing the square just inside the parentheses. So inside the parentheses right now, we have x squared plus x divided by -3. You can actually rewrite that middle term. You can see we have both a plus and a minus sign there, so you can just make it minus. And instead of writing it as x over 3, you can also write it as 1/3 x, if you like. So when you are completing the square, and again, if you remember this from the previous chapters, the idea is you take the coefficient of your middle term, divide it by 2, and then we square the whole thing. And if you remember, I had told you if b, our coefficient b was a fraction, instead of dividing by 2, you can also multiply by 1/2 and it gives you the same result. And then you can square the entire thing. So since our middle coefficient is that fraction 1/3, we're going to take the 1/3 and multiply it by 1/2 and then square the whole thing. So what do you think that answer will come out to be? Yeah, very nice, because when we multiply on the inside of the parentheses, 1 times 1 will give us 1, 3 times 2 will give us 6. And when you take the square, as Abdul Aziz had in the chat, you will end up with 1/36. So 1/36 is what we need to complete our square inside the parentheses part. Okay, that's fine, Oliver, not a problem. So what happens, guys, if you remember again when we had talked about completing the square in the previous 2 chapters, this 1/36 traditionally would have been added to both sides of our equation, obviously to maintain the balance of our equation and not to change any value. Since we're not able to add anything on the left-hand side where we have the y, we will be adding and subtracting this 1/36 on the same side. So by adding it and then subtracting it, it's kind of like you're adding 0, right? Which means you're not changing the value of your equation. So that's what we're going to end up doing over here. We're going to take that positive 1/36 and we're going to add it and subtract it at the same time. Okay, and then don't forget that -1 on the outside. Now for completing the square, we actually only need the first 3 terms. We don't need the -1/36. So what we're going to do is bring this -1/36 outside of the parentheses, and to bring it, excuse me, outside of the parentheses, we actually need to multiply it with this -3 in the front. So you need to multiply this -136 with -3 when you're bringing it outside of the parentheses. So you should be left behind with -3 on the outside, x squared minus 1/3 x plus 1/36 inside the parentheses. So the first 3 terms. And now we will be multiplying so we will be multiplying, let's see, -3 with -1/36. And what do you think this will clean up into? Okay, let's see. So you have, very nice, Nathan, James, and Lowell, 1/12. Yeah, because the 2 negatives, Javier, same thing. Yeah, very nice. The 2 negatives will, of course, end up becoming positive. So the 2 negatives will become positive, and then 3 can go into 36 12 times. So very nice. When you simplify this, we'll just have 1 over 12 left behind. So when you are bringing this number outside, it's going to be positive 1 over 12. And then don't forget that minus 1 from the beginning. And you're almost there. So at this point, we will need to factor this out. We will need to add both of these numbers, and we should be able to get our equation from the standard form into the transformation form. So we will still have that negative 3 on the outside. Now let's take a look at our x squared minus 1/3 x plus 1 over 36. So we need to factor this. And what do you think this will factor into? Okay, Abdul Aziz, you've got x minus 1 over 6 to the second power. So basically your x squared, of course, just breaks down into x and x. Okay, Oliver, same thing, Nathan. And then 1 over 36 basically is the square of 1 over 6 and 1 over 6, and then, you know, the minus for our sign in there. So basically you can verify that if I multiply negative 1/6 with negative 1/6, I will definitely end up getting positive, 1 over 36. So when we multiply, we get positive 1 over 36. When we add negative 1/6 with negative 1/6, of course, this will add into negative 2 over 6, which simplifies to negative 1/3, and that's our middle term. So you can see those verify. Additionally, I don't know if you remember this or not, but I had told you, you can also look at this value in here right before we did the square. So whatever this number is, that's also what your trinomial factors down into. So that's that same 1/6 basically that we are using here in our factoring. So this will factor into, as Abdul Aziz has it in the chat, as x minus 1/6 to the second power. And then what happens when we add that 112 and negative 1, or basically if you subtract those numbers? What will that give us? Nathan, you've got negative 11 over 12. Abdul Aziz, negative 11 over 12. Okay, so remember, guys, what happens here is the minus 1 that we have at the end. Of course, we will need to make that into a common denominator. So if right now we think of that denominator as being 1, to make it into a common denominator, you would multiply this by 12. So we would basically end up with 112 minus 12 over 12. And you can see when you do 1 minus 12, that's where the negative 11 over 12 comes from. And that's the last part we got to do. So you would have negative 11 over 12 on the outside. So now you can see we have taken this equation from the standard form into the transformation form. We've got negative 3 for our A value. We've got 1/6 for the H value. And then, of course, we've got the negative 11 over 12 for the K value. So now all we have to do is put this into our answer box and check our answer here. So let's see what that will come out to be. Okay, so negative 3 parentheses x minus 1/6, the whole thing to the second power, and then minus 11 over 12. Alrighty, very nice. Okay, so let's clear this out. And now they're asking us to graph this. So if you will graph this, and you will notice when we actually try to graph this, we know this is a parabola because it's an x squared function. So you'll pick the, x squared tool, and then you click on the graph And you will notice the moment we clicked on the graph, this little pop-up box shows up. And they're asking us to type in the values for our stretching or shrinking, vertical translation, horizontal translation, and then do we have reflection with respect to the X and Y axes. So basically, you know, our equation was y equals -3, x minus 1/6 to the second power minus 11/12. So, oops, there we go. So what do you think we should put in this stretching, shrinking box? Yeah, very nice, Abdul Aziz. The A value is what gives us the stretching or shrinking, but you're actually just going to be typing in 3, not the negative. Okay, then what do you guys think about the vertical translation? What's making our graph move up or down? Yes, it is going to be the K value, which is at the end, the -11/12. And for this one, you do want to include the negative sign. It's just on the stretching or shrinking, we do not include the negative. Okay, what do you guys think about the horizontal translation? Yeah, so Nathan, you have -1/6. Abdul Aziz, you have +1/6. So remember, guys, in general, by default, our equation is x minus h. So since you have in the parentheses x minus h, remember we think of h as being a positive value. So when you're saying x minus 1/6, that means the number itself is actually positive. If you had x plus 1/6, that means the 1/6 would be negative. So remember, with the h value, we always go with the opposite sign. So again, we will have positive 1/6 in our box over here. Okay, so you still have that negative on the 3. And remember, that negative means we have a reflection on our graph. So if the parabola is going to be opening up, then you know the reflection makes it open down. Or if it was originally opening down, the reflection makes it open up, which means for these parabolas, the reflection always happens in terms of the x-axis, not the y-axis. So that box for the y-axis is basically there to throw you off. You are only going to be selecting the x reflection in the x-axis. But one thing you should notice, the moment I clicked that box for the x-axis, my negative sign in the vertical translation disappears. So make sure you put that back in. I don't know why it does that, but every time I have worked on this problem, anytime you click on one of those boxes for the reflection, those negative signs disappear. So make sure before you submit your answer, you get that negative back in. So now look at the graph. We've got the graph moving down. So it's moving below the x-axis in this case. You can see it's moved slightly to the right because that's our horizontal translation of 1/6. And then you should see the parabola itself is a little bit narrower, you know, than what our x square parabola would be. And that's because of that stretching that's happening with the number 3. So once you get all those boxes typed in, we can save our graph. And then all we have to do is check our answer at the end. Questions on this one, guys? So I know it's kind of, you know, following these different steps, and I have not laid everything out, but I am kind of talking about the different things that are involved in, you know, converting it from the standard to the transformation form. So just to make sure you guys are comfortable with this example, let's do a similar question on this one and pick another example. And you can see just a little bit different than the first example we did here. And let's see what this guy would look like when we try to put it in the transformation form. So we are given y equals, okay, so negative 2 x squared plus 7x minus 2. So again, our leading coefficient we know should not have that negative 2 on it. So we're going to factor out the negative 2, which will leave us behind with x squared. Again, 7, 2 will not go into 7. So like we did in the previous example, go ahead and divide that middle term by the negative 2. And then at the end, we will have the minus 2. Okay, Trey, that's fine, not a problem. So let's just go ahead and clean that up and let's see what we have. So minus 2 on the outside. We have x squared. And then positive 7 and negative 2 will basically just make that into negative 7/2 x. And then this is where, that completing the square part kicks in. So again, remember, since we have a fraction over here for our b middle term coefficient, we'll go ahead and take our b value, multiply by 1/2, and then square the whole thing. So that will be basically our 7/2 multiplied by 1/2, and then square that. And what will that come out to be? Just 49? Yeah, it should be a fraction, right, James? You should have the 7 on the numerator, because when we multiply this, we would have 7 times 1, which is 7 on the top. 2 times 2 would be 4. And then when we square it, that, of course, as you guys have it in your answer, is 49/16. So coming back to our equation, then we've got our x squared minus 7/2 x, and then remember, this is where you add and subtract this number at the same time. So add 49/16, subtract 49/16, and then we still have that minus 2 on the outside. So completing the square, we just need those first 3 terms. So as we had done in the previous example, you're going to take this minus 49/16 and multiply it with the negative 2 on the outside. And what will that come out to be? Let's see, what did you guys have? Okay, so Abdul Aziz, you've got 41/8. When you multiply negative 2 with negative 49/16, yeah, there we go. So again, the 2 negatives will become positive, and then 2 goes into itself once, goes into 16 8 times. So yeah, you should get 49/8 from here. And that's a positive, so you'll be bringing 49/8, and then we still have that minus 2 at the end. And we're almost there, so now we have to factor this, guys, and we have to add these 2, and we should be on our way. So again, what will this factor into our trinomial? And this is going to be a perfect square trinomial, so both our factors have to be the same thing. So what will that factor into? Okay. X minus 7/4 Alrighty, yeah, very nice, because again, use this number here right before we squared it. So x minus 7 over 4. Again, when you multiply negative 7 over 4 with itself, you get 49 over 16. When I add negative 7 over 4 with negative 7 over 4, we get that middle term of 7/2. So that will be perfect. So negative 2 on the outside. This factors into x minus 7/4 to the second power. And then what happens when you add that 49 over 8 with negative 2? Or subtract. So you have 33 over 8. That's fine, Javier. Abdulaziz, Nathan. Nathan, you have 33 over 16. Abdulaziz, 33 over 8. Shayna, Lowell. Okay, Nathan, I see you fixed your answer. Yeah, because like we saw in the previous example again, right? We make our common denominator for that second fraction. And then when you subtract them, you have 49 over 8 minus 16 over 8, which will, like you guys said, come out to be 33 over 8. Alrighty. And that will be a positive 33 over 8. And yeah, there we go. That's going to be our equation from the standard into the transformation form. This is what we're looking at. So again, let's go ahead and type this in. So that will be negative 2 on the outside, x minus 7/4 on the inside. Raise that to the second power and then add 33 over 8. Okay, that looks good. And then, again, they're going to ask us for the graphing. So click our parabola. And again, tell me what you're going to put in these boxes. So let's start with that stretching and shrinking box here. Yeah, very nice. Good job, guys. Just the number 2, not the negative sign. So this guy will become 2. And then for vertical translation, Lowell, so it will just be positive 33 over 8 because that's what we have here. So this guy will actually was positive, so it will stay positive. It's only for the horizontal translation that we change the sign. Okay, and then the horizontal translation, what are we putting in there? Oh, okay, Lowell, no problem. So Alicia and James, you can see how inside the parentheses we have x minus 7/4. So that means 7/4 itself actually is positive. So go with the opposite sign than what you see inside the parentheses. So x minus 7/4, which means 7/4 itself is positive. All right, so yeah, that's what Shayna, Nathan, Trey, you guys had. All right, very good. So positive 7 over 4. And then what do we do with that negative sign in front of the 2? So for the negative sign in front of the 2, what are we going to do? Yeah, and with which axis? The reflection for which axis? Because there's 2 boxes. Always the X. Yes, very nice. Another thing to remember. And so we're going to click reflection with the x-axis, and now you will see we did not have a negative in front of the 33 over 8, but the moment I click that, it brings a negative in. This is a funky, I don't know what's wrong with their programming, but it always ends up doing one or the other, either removes it or adds it. So make sure you remove that negative sign from the vertical translation. That should be a positive 33 over 8. Everything else looks good. We've got 2 for the stretch. 33/8 positive for the vertical, positive 7/4 for the, yeah, because, and that's my reasoning too, Abdul Aziz. I think it's because of the reflection on the x-axis. Sometimes it makes it think it should be moving in the opposite direction than what we typed in. So yeah, just verify your numbers are correct. We'll save our graph and then do a check. And there we go. So just to show you, kind of how this example can give you a little bit of a different equation every time you are clicking on it. So did anybody have questions on this before we move on? No? Alrighty, so let's take a look at the next type of example. And this is actually where we are getting into the discussion for some of the different properties of our graph. So we're talking about opening, if the graph opens up or down. So basically, if that A value is a positive number, your graph is going to be opening upward. So, of course, our parabola, the arms are going to be up, going towards positive infinity, basically on the y-axis. If the A value is negative, then your graph is basically opening downward. Because think about it, when you have negative in front of that A in our equation, that creates a reflection, right? So if A is positive, obviously we're opening up. If we put a negative in front of that A, it's creating a reflection, and that reflection is basically what's making our graph open downward. So you can relate this with the idea of our reflection, and because of that reflection, our graph ends up opening, downwards. So opening is something that really makes a difference as we talk about the other properties over here. Now, we have not officially, but briefly talked about the vertex in the last chapter, but basically the idea is if your parabola is going to be opening upwards, then the vertex of our parabola is going to be the lowest point on our graph. And, of course, if the parabola is opening downwards, then the vertex is going to be the highest point on our parabola. And you can see in both these graphs, we have the ordered pair HK for our vertex coordinates. Whether it's opening up or down, it doesn't matter. Your vertex is always going to be at HK. And those values of H and K are basically coming from the equation of our parabola when it's written in the transformation form. So if your equation is going to be in the transformation form, it really becomes easy to find what the vertex of our parabola is going to be. And we're kind of talking about that here in the paragraph here. So the point HK is what we call as the vertex of our parabola. However, if your equation is not given to you in the transformation form, but the equation is given in the standard form, then you actually have to use this little formula over here. This helps us find the x coordinate for our vertex. You can kind of think of that as being our h value. So negative b over 2a will help you come up with the x coordinate. And then for the y coordinate, you basically use, substitution. You put it back into the equation, and that will help you come up with the vertex for your equation in the standard form. So for the transformation form, you just have to use the ordered pair HK for the vertex. For the standard form, you have to use for the x variable negative b over 2a. For the y variable, we're basically plugging it back into the equation to find that y coordinate. Okay, Oliver, sorry about that. I'm glad you were able to get back in. So let's take a look at, how we can find the vertex of our parabolas based on the different type of equations we have. So let me see. Okay, so let's do this guy over here. So the equation is given to us as y equals x squared plus x. And to find the vertex, basically we will have, since this is in the standard form, to find the vertex, you can do negative b over 2a. So that's got to be negative, and then whatever, that b term is going to be divided by 2 times a. So looking at our equation over here, what's the b coefficient? Yeah, very nice, because that in front of that x, you can think of that as being a positive 1. So b will be positive 1. And what do we think about a? Yeah, same thing. You have x squared, so the number in front is again going to be 1. So as you can see, James has the answer over there. You will have negative 1 on the numerator, 2 on the denominator. So this will give us the x value for our vertex. So that's going to be negative 1/2 for the x. Now we have to find the y coordinate. Now to find the y coordinate, you basically take this answer that you came up with for the x and put it back into your function. So that means you will end up getting x squared plus x. Everywhere you have x, replace it with negative 1/2. And when you solve that, clean that up, what are you going to end up with? Okay, so you've got Abdul Aziz and Shayna, negative 1/4. So let's take a look. This will be negative, and negative will become positive on that first part. 1 times 1 is 1. 2 times 2 is 4. So positive 1/4 from that first one. Oliver, you also have negative 1/4. And then you have plus or minus. So that will just become minus 1/2. So from 1/4, we are subtracting 1/2. And James, you have the same answer. So guys, again, find your common denominator. So to find our common denominator, we'll multiply this side of our fraction by 2. And that will end up giving us 1/4 there we go, 1/4 minus 2/4, which will of course then end up giving you the negative 1/4 you guys were coming up with. So this is going to be our y value, negative 1/4. Okay, so that's how you can find the vertex for this parabola. And as you can see, guys, our a value was a positive 1, which of course is telling us our parabola is going to be opening upwards. And that will make this vertex the lowest point on our graph. Alrighty, so that was using the standard form of our equation on finding the vertex. Now, for this next example, and this is again we were talking about here, if it's given to you in the transformation form, then you just have to find the ordered pair HK. So you can see that in that little box for the vertex of our parabola. So based on that, what do you think the vertex of this parabola is going to be? Let's see, you guys have negative 3 and 3, James. Abdul Aziz, you've got 3, negative 3. Oh, come on, you can do better than that. Yes, Shayna, very nice. Both numbers are positive. Remember, you have to go with the opposite sign for the h value. So since you are seeing x minus 3 inside the parentheses, that means h itself is the positive 3. And then k, k is whatever sign. So if it's positive, keep it positive. If it's negative, keep it negative. Be careful with your signs, because honestly, that's where I have seen the error happen, is on the signs for the h number. So be careful with that, guy. Alrighty, and that's all you have to do. So no calculations involved, when you have the transformation form. Let me see. Yes, Oliver, a value can definitely be 1. If you look at the previous example, let me open that. So if you look at this example over here, you can see our A value is, definitely 1. Or are you saying, can it be I? So you're kind of thinking in terms of imaginary numbers here? Usually for the vertex, we do not deal with imaginary numbers, because remember, for these guys, we try to keep our domain and range within the real number. So you're only going from negative infinity to positive infinity. So yeah, that means you will not be able to have I or imaginary numbers for any of these values. And if they are going to be imaginary, they will be more in terms of the solution of our quadratic equation, kind of like what we had seen in chapter 2, but not in terms of points on the graph. Okay. Alrighty, yeah, not a problem. Wonderful. Okay, so that was just finding the vertex for our parabolas. Now, what I wanted to talk about is some of the other properties for our parabolas here. So basically, again, if your equation is given in the transformation form, as far as the domain of these quadratic functions goes, they are going to be all real numbers for the domain. Because remember, since this is a function, your parabola cannot open on the side, because, if it's opening on the right or the left, they will not be a function. They will fail the vertical line test. So since these are functions, we know our parabola has to open up or down. So their domain will always be all real numbers, no matter what. But the range of the function can change, because if your function, your parabola is opening up, then, of course, your y values are headed up towards positive infinity. If your parabola is opening downwards, that means your y values are headed towards negative infinity. And then based on your vertex, you will see we are actually using that k value to determine our range. So if your parabola is opening up, which means the a is a positive number, the range of our function is going to go from k to infinity, including k, because that means our parabola is opening up, and the vertex is going to be the lowest point on our parabola. So you will be going from k to positive infinity, including k, and at the same time, that k value that we have is called the minimum value of the function, because we know our y value cannot get any smaller than whatever that k is, because k is the smallest value on your function. That's the lowest point on your graph. Now, if we switch our graph and, instead of opening up, our graph is opening downwards, which means the a is a negative number, then see how the range will change. Your range is now going to go from negative infinity to k, and it stops, wherever that k value is going to be, because now k becomes the maximum point on our function. It's going to be the maximum value. So if your parabola is opening downwards, the range is negative infinity to k, including k. If the parabola is opening upwards, the range is going to be k to infinity, including k. And then look at these intervals for where the function is increasing and where it's decreasing. If the parabola is opening up, the function will decrease on the interval negative infinity to h. It is increasing on the interval h to infinity. If your parabola is opening downwards, again, your increasing and decreasing will switch places also. So it's going to be increasing on negative infinity to h, and it's going to be decreasing on h to infinity. So just by knowing what these h and k values are, we can come up with the range. We can come up with the maximum or the minimum value of our function. We can also see where our function will be increasing and decreasing. If your equation is given to you in the standard form, I would say start by finding your vertex first. Once you have your vertex, you can again go ahead and calculate these things based on that value of the vertex. One other thing is you have your axis of symmetry. You know, in chapter 2, we had talked about how even functions have symmetry with respect to the y-axis and how odd functions have symmetry with respect to the origin. So this is still talking about symmetry, but remember, parabolas bring their own symmetry. So parabolas will have this axis of symmetry, which will be a vertical line that passes through the vertex of the parabola. So look at that equation for the vertical line for the axis of symmetry. It's the same formula as what we used to find our x coordinate for the vertex. That's the exact same formula they're using here. You know, if this was an equation with the transformation, then this would change to x equals h, but this is again your axis of symmetry. So find the vertex and you can find, like I said, your axis of symmetry, your range, the maximum minimum value, and on which interval is your function increasing and decreasing. So you have this example over here, which is very similar to what you have here in your homework. So I'll let you guys work on this example on your own, but let's take a look at this guy here. So they're asking us to find the range, the maximum or the minimum value, and then they want to know the intervals over which the function will be increasing or decreasing. Step 1, what is the vertex of this parabola? Okay, so I've got Abdul Aziz, James, Lowell, Trey, positive 8, negative 3. Very nice, good job. So positive 8 for the h value, negative 3 for the k value. Very nice. Oops. Okay, so the first number gives you the h, the second gives you the k. Can you tell me if this parabola is opening up or down? Yeah, very nice, because you can see there's no coefficient in front of that x minus 8, which means it's understood to be a positive 1. So that's telling us our parabola is opening upwards. Okay, so basically what we have is a parabola that opens up with this vertex being the lowest point on our graph. Okay, so can you tell me what the range for this function should be? Because we know the domain is going to be negative to positive infinity. Let's see, James and Abdulaziz, you guys have negative 3, yeah, to positive infinity, because your graph is going up. So our vertex is 8, negative 3. So remember, you start at the lowest point and you go up to positive infinity. And looks like Nathan, Shayna, you guys are saying the same thing. Trey and Oliver, negative 3 to infinity, including negative 3. Very nice. Yeah, so negative 3 to infinity, including negative 3. Okay, so let's type that in here. What did I do? There we go. Okay, what's the minimum value for this function? It's always k. Yeah, it's always that second coordinate from your vertex. Very nice. So it is going to be negative 3. Alrighty, very nice. That's our minimum value. Oops. Please check that. All right, now take a second and think about this. Where is your function increasing? What interval is it increasing at? And if it helps, you know, draw a bigger graph. Oops. So it's a parabola opening upwards on your vertex. This is 8, negative 3. So let's see, Abdulaziz, Trey, and Shayna. James, you guys are going from 8 to infinity. Yeah, and I actually just noticed that in the handout, my math lab wants you to use brackets instead of parentheses. That's a conflict your textbook and I constantly have. Yeah, you have to include H for this textbook, Abdul Aziz. If you remember, I was kind of mentioning this last time. You know, when I learned increasing and decreasing, the idea was we were just defining from which X values, you know, it increased and decreased. So we never included the endpoints. But your textbook, which means your author for the textbook, does it a little bit differently. So they want you to put brackets instead of parentheses for all intervals for increasing and decreasing. So we will be using brackets here. So yeah, very nice. So you can see as we start at that vertex of our parabola and go to the right, our graph, we are having to go upwards. So since we're having to go upwards, that means our function is increasing on this side, which means in terms of the X values, we know this part of our graph would be heading towards positive infinity. So it is increasing from 8, which is your X value over here, to positive infinity. So what do you think the interval for decreasing will be then? Where is your function decreasing at? Yeah, you're just going in the opposite direction. Very nice. So you're going from negative infinity to 8. So that means if we start on the left-hand side of our graph, you know, we would be moving downward over here. And since you would be moving downwards, that means our function is decreasing on this side. And that means it's coming from the negative infinity side and it stops at 8. And again, guys, remember, include your number in this case. So very nice, Shayna, Oliver, yeah, Javier, very good. So this will be for the increasing, which was going from 8 to infinity. And then for decreasing, we are going from negative infinity, negative infinity to 8 with a bracket. Alrighty, nicely done. Did you guys have any questions before we move to the next one? No? All right, so this guy is actually similar to what we talked about, but as you can see, your equation is given in the standard form. So again, the first thing we're going to do is start by finding the vertex for this parabola. So remember, for the vertex, use that equation x equals negative b over 2a. Okay, so James came up with negative 4 and positive 4, so let's verify that. So start with x equals negative b over 2a. So that's negative. What's our b value over here? Yeah, and a? Yeah, because you can see the coefficient of our x squared is just going to be 1. So this guy basically comes out to be negative 4 over 2. So James, how did you get negative 4 and 4? Because this guy will become negative 2 for the x value. Yeah, so just be a little careful. Shayna, you've got negative 2, 0. Robert, looks like you also came up with that. Put this back in to our equation to find the y value. So that's x squared, which is negative 2 squared, plus 4 times x, which would be 4 times negative 2, plus 4. So let's see. Okay, James, not a problem. Slow down a little bit, okay? So negative 2 squared would give us 4. In the middle, 4 times negative 2 becomes negative 8 plus 4. So yeah, 4 minus 8 gives us -4. -4 plus 4 will end up giving us 0. So very nice. Our vertex is going to be -2, 0. So let's put that guy in. Alrighty, can you tell me what our axis of symmetry is going to be? Is it going to be part A or part B to even begin with? Because remember, it's got to be an equation. It's a line, so you are writing an equation. We know axis of symmetry is going to be a vertical line. Okay, Oliver, you are saying it's got to be B. Nathan, you're saying A. Shayna, you're also saying A, okay? Yeah, because Oliver, since this is a vertical line, it's always going to be x equals format. So it is going to be part A. And then what number are we putting in there? It comes from your vertex. Yes, it's always going to be that x coordinate from your vertex. So it's always going to be the same number that we came up with for our vertex. So we are putting in -2 over here. Very nice. Okay. Can you tell me if you remember how to find your y-intercept? What do we have to do to find the y-intercept? We had talked about this in chapter 1, and I believe in chapter 2 also, or maybe chapter 1 for sure. Very nice, Abdul Aziz. Yes, so guys, to find the y-intercept in your equation, you make your x variable 0. So if we make our x variable 0, what will that end up giving us? And this is going to be an ordered pair. So as an ordered pair, what are you going to have? Very nice. Yes. So our x value will be 0. And then, of course, you can see these guys basically disappear when they are multiplied with 0, leaving us behind with the 4 that you had. And then as an ordered pair, you have to write x was 0, y is 4. Okay, doing good, guys. Your next question is going to be, how do you find the x-intercept? So let me see what you come up with for the x-intercept. Shayna, you had -2, 0. Oliver, same thing, -2, 0. So, you know, just like for the y-intercept, we took our equation and we made our x 0. For finding the x-intercept, you have to make your y value 0. Very nice, Nathan. You also had that same thing. So in this case, you would actually have 0 equals x squared plus 4x plus 4. And then you would actually either factor your right-hand side, or you have to use the quadratic formula. So it's up to you which method you're comfortable with. This is exactly what we had talked about in chapter 2. Technically, you can also use completing the square to solve this. So it's really entirely up to you. I think factoring is going to be the easiest way to move forward with, because you can break down that 4 into 2 times 2. The 2 times 2 gives you 4, and then 2 plus 2 adds up to give you 4, which will be our middle term for the 4x. So you can see this guy will factor into x plus 2, x plus 2. Take that x plus 2, set it equal to 0, and you will see your x value comes out to be -2. So x is -2 when y is 0. So let's type that in. And you should notice this is the same ordered pair as the vertex of our parabola because that was also negative to 0. So if you think about this graphically, technically our graph is actually sitting right on top of the x-axis. Basically, that's what this guy will come out to be. So let me clear all of this out. And our last question is asking about our parabola is opening up or down. So looking at the equation of our parabola, what would you say? Is it opening up or down? Yeah, your A value is a positive 1. And since it's positive, your graph will be opening upward. So just a drop-down menu, you select your answer from. And we are good to go over here. And I think the last part is going to be about the graph. So click on the graph. And this one, again, we know this is a parabola, either opening up or down. So pick that tool. Now, if you notice, and let me make this guy a little bit bigger. Okay, so once you pick your tool, you will notice in the little yellow strip in our box, it's telling us to plot the vertex of our parabola. So remember the vertex was at negative 2, 0. So that's going to be right here. Okay, Oliver, I'm sorry about that. I'm not sure why Zoom is giving you so much trouble today. So one thing you should notice is that little pop-up box did not open, with the stretching, shrinking, vertical, and horizontal translation. That does not happen in this graph. So you literally just start by plotting where the vertex is going to be, and then you can either use the x-intercept or the y-intercept to graph the other point. Since our x-intercept is the same thing as, the vertex, then of course that means we want to use the y-intercept for our second one, which was at 0, 4. So get our graph in there. You just need those 2 points. We'll save that, and we should be able to check our answer after that. There you go. Okay. Any questions on this one, guys? So you have one example where they're giving you the equation in the transformation form, which is what we did in the previous example. And then this one here is in the standard form. But you can see once we have the vertex, a lot of these things can follow along from there. Of course, x and y intercept, we will need to calculate those. All right, let's talk about how to solve these quadratic inequalities. Okay. So when we are solving our quadratic inequalities, you will see there's 2 different ways we're going to be doing this, using the graphical method, and then we also have what we call as the test point method. So right now we're looking at the graphical method. So basically, once you have the graph of your parabola, and which is what we are given over here, we already have the graph. You actually have to see which part of the graph will satisfy our inequality. So we are given x squared minus 5x minus 6 is greater than equal to 0, which means basically this is our y value, the the expression, quadratic expression here. And so we basically want to know where is the y value going to be greater than 0 and where it is equal to 0. So if you look at this graph, and let's make this guy a little bit bigger over here. First thing is go ahead and identify where the graph is crossing the x-axis at. What points are those? Okay, so you're saying -1 and 6. Okay, so looking at this over here. Yeah, so this point over here on the left-hand side where our graph is crossing the x-axis at. You know, this pen is working great sometime and it's not. I have requested for new batteries, so whenever they get here, hopefully this pen will behave better. If it will let me write. Okay, so this point here is going to be the ordered pair -1, 0. And this point over here, of course, will be the ordered pair +6, 0. So if you had to identify your interval, and remember, interval is always in terms of the x values. At which interval would you say your y value is greater than or equal to 0 at? What would those intervals look like?
Wouldn't it just be those two?
Like just the numbers, -1?
Yeah. Oh, wait, greater than, okay, never mind.
Yeah, so this is where your y value is equal to 0, right? But we also know where it's greater than. Okay, so let's see, James, you sent something. You're saying from -infinity to -1, including -1, and then union. Did you mean to have that parentheses in there or just the bracket? Okay, so then you're going from 6 to infinity, including 6. Very nice. Yeah. So as you can see, and as James has over there, he's saying, okay, let's start from -infinity, which would be on this side. And we're going all the way to -1, and we are including -1. So you can see where our x values are between infinity and -1. Yes, our y values are going to be positive on this side. Right at this point where the x-intercept is, our y value is equal to 0. And then you're picking back up from number 6 over here and you're going towards +infinity. So again, in that range, or sorry, in that interval, again, all our y values are greater than 0. And then right at that ordered pair for the x-intercept, your y value is equal to 0. So very nice, James. You're going from -infinity to -1, including -1. And then you picked up from 6 to infinity, including, and then, yeah, using the union to combine those two together. Very nice. So let's go ahead and type that in. So -infinity to -1, including, and then union, including 6 to infinity. Alrighty, very nice. So, you know, graphical method like you saw, just look at the graph, you know, pick your ordered pairs where the x-intercepts are, and then those kind of help you break down where your function will be greater than or less than. Now, with the test point method, you know, basically what we are doing is skipping that whole come up with your own graph. You know, of course, in MyMathLab, they give you the graphs, but if you were doing this on paper by hand, we would be drawing our own graphs. So what happens with the test point method is, you know, get your inequality with 0 on one side and your quadratic expression on the other side. And then they're asking you to find all the roots. So basically when they're saying find all the roots, what they mean is find your x-intercepts. So you can think of roots as being either the solutions. This will let me. Right, come on, buddy. Okay, it's not letting me write. Okay, so with the roots, we're basically talking about either finding the solutions for our quadratic equation, or you can think of that as your x-intercepts, okay? And so basically, you know, like I said, get 0 on one side, get your quadratic polynomial on the other, find all your roots. And then the idea is we actually select a test point from each of those intervals. So once you find your roots, the idea is we would put them on a number line, which basically represents our x axis. So you would have your x-intercept. If you have more than one x-intercept, then, you know, let's say we have two of them, we would mark them on our number line. Then from each interval, we would select what our test point should be. So we would be selecting test points from each interval. And then the idea is you take those test points and put them in your quadratic formula, in your quadratic polynomial, because we want to know, is the y value going to be positive or negative in this interval? If your y value is positive, then, you know, of course, we are saying that means y is greater than 0. If your y value is negative, then, you know, of course, that's where your y value is going to be less than 0. And at the x-intercepts themselves, we know the y value is always equal to 0. So it works very similar to what our graph method does, but like I said, you're skipping the process of drawing your own graph. So if we come back and look at our, you know, graphing method over here that we had, oops, sorry. It basically works in that same way. So what you would basically do is we would have our x-intercepts over here. Then from each of these intervals, let's say we would pick a test point, let's say this number over here, this one over here, and this one over here. So we would then put these numbers into our quadratic polynomial, and you would see we would get a positive y value over here. Here, our y value would be negative. And then on this interval, our y value would be positive. And then by looking at our quadratic inequality, we would know where we have y greater than 0, y less than 0, and all of that. With the only exception, you wouldn't have this graph to look at for your you know, polynomial function. So let's try and put that test point method to the test in a way and see what we come up with. So we've got this example over here, s squared minus 2s minus 6 is less than 0. So as you can see, we've already got the polynomial on one side and 0 on the other side, so we don't have to rearrange it. So we can actually directly start by finding our roots, our solutions. So I am just going to take the s squared minus 2s minus 6 and actually set it equal to 0 so that we can find our roots. You can use factoring, completing the square, or quadratic formula. What would you prefer? Do you think factoring will work in this example? Because if we were looking for factoring, we're trying to find two numbers that multiply to give us negative 6, but add up to give us negative 2. Yeah, Abdulaziz, you're saying it cannot be factored? Yeah, because 6 is going to be 6 times 1, and either you add or subtract those numbers, we don't get negative 2. The other combination for 6 would be 2 times 3, and again, either you add or subtract the 2 and the 3, we do not get a negative 2 either. So like I said, if factoring is not working, you can use completing the square or the quadratic formula. Let's do a quadratic formula here. And just to remind you of your quadratic formula, it's going to be x equals negative b plus or minus square root of b squared minus 4ac, and then the whole thing divided by 2a. Instead of x, we are using s as our variable. The same thing, negative b plus or minus square root of b squared minus 4 times ac divided by 2a. Plug in your a, b, and c and see what you come up with. Okay, so I don't think you're going to get a happy answer. Um, since we were not able to factor this, then you should be getting something that's an irrational. And looks like, Nathan, that's kind of what you came up with, 1 plus or minus square root of 7. Okay, so let's see what happens over here. So what's our b coordinate over here? B coefficient, sorry. Yeah, very nice. That's going to be the coefficient of our middle term. So that's going to be -2 and -2. What's the a? Okay, James, you've got 2 plus or minus square root of 7. Oliver, you're saying the same thing. A value is going to be 1, so that's going to be 1 and 1 over here. And then what's the C? Yeah, very nice. That's a constant term, -6. So let's see. When we try and simplify this, we will end up with +2 at the front, plus or minus, let's see, -2 squared, 2 negatives become positive. That will be a 4. -4 times 1 times -6. So 2 negatives will become positive. 4, 6 are 24. And then, of course, in the denominator, 2 times 1 will become a 2. So you have 2 plus or minus, what is that, 28 divided by 2. Okay, and that's where I can see where you're getting your square root of 7 from. So square root of 28 will need to be simplified. You cannot leave it as square root of 28. Even though it's not a perfect square, you can simplify that 28 into 4 times 7. And square root of 4 will come outside as 2. And the 7 will continue to stay inside the radical. So that's kind of how you have to break that square root of 28 down. So basically that ends up giving us 2 plus or minus 2 square root of 7 divided by 2. So remember, this is where we separate that denominator with the plus or minus sign. So you should have 2 over 2 plus or minus 2 square root of 7 over 2. So it looks like, James, you still had a 2 that's behind on that first term, because that should cancel out to become 1, right? So you should have 1 plus or minus square root of 7. And I know, Nathan, you had that. Oliver, is that what you also had? Yeah. So yeah, James, looks like you simplified the 2 from the square root of 7 side, but not from the first part, right? Oh, you squared the minus b at the start. Interesting. Yeah, because that would have given you the 4, which divided by 2 became a 2. Then I see. All right, got to be a little careful then. Got it, got it. Yeah, yeah, interesting. Okay, so as I was telling you, not happy numbers, but that's okay. So you're going to put this on the number line. So, of course, 1 minus will be the smaller value, 1 minus square root of 7, and then 1 plus square root of 7. Now, our next step is finding these test points. But, before we can find the test points, we actually need at least a decimal answer for what 1 minus square root of 7 and 1 plus square root of 7 is going to be, because without that, how are we going to find these test points? So just round it to 1 decimal place. Can you tell me what that 1 minus and 1 plus square root of 7 comes out to be? Okay, Oliver, I'm guessing that's for the 1 plus. If you're getting the 3.65, yeah, okay. You know what, let me put that in a different color. So you've got 3.65. Okay, and then for the 1 minus, what are we getting as an approximate? Yeah, it should be a number smaller than that, so 1.654. And again, remember the decimal is just for us to be able to come up with these test points. They are not going to be part of our answer. So from that leftmost interval, what would you guys like to select as your test point? For this side over here? We're working from left to right. Okay, you want to go with -2? Yeah, as long as that number is smaller than -1.65, you should be good. So you can use -2 over here as our test point. Okay, what about the middle between the two x-intercepts? You want to go with 0? Okay, that would be fine. 0 is between -1.65 and 3.65. And then I guess Abdulaziz, you wanted to do 4 for that right-hand side. So as long as that's a number larger than 3.65, you are good to go. So now that we have our test points, you are going to take these test points and you are going to check using this inequality, s squared minus 2s minus 6, because now we have to see, will we get a positive answer from that, negative, or, you know, well, I guess those are the only two options. So let's check and see. So we'll use s as -2. And when you plug that into this polynomial, what do we get? You are getting +2 on that, Abdulaziz. So let's see, that would be -2 squared, which is +4. -2 times -2 would be +4. So that's 8. 8 minus 6 would be 2. Okay, very nice. So this will come out to be 2. And you know, for that means that's a +2. So that tells us all the signs here are going to be positive in this interval. Now let's check for the second interval where our test point is 0. What will that end up giving us? Okay, very nice. Nathan, Abdulaziz, you guys have -6 here, which means all the signs here are going to be negative, and then the very last one, test point of 4. James, you've got 2. Alrighty, so again, that's a +2, which means everything in this interval is going to be positive. Again, looks like Nathan and Oliver, you guys also got +2 on that last interval. Okay, now our inequality, guys, is where is our inequality going to be less than 0? So what do you think you will select as your solution set over here? Where is our inequality going to be less than 0 at? Okay. Oh, Ryan, I was wondering, yeah, what happened to you? Okay. So Abdul Aziz, remember, we cannot use the decimal answers. If you look at the instructions, they want interval notation with the exact answer using radical. So how will you modify your answer? Yeah. Except, James, we don't need that negative in the front, but yeah, 1 minus square root of 7 and 1 plus square root of 7 looks good because it is going to be between here, right, where we have a negative value for our y. So that means it's going to be this interval right here in the middle. And since this is a strictly less than inequality, there's only less than 0. That means we are not including our endpoint. So going from 1 minus square root of 7 to 1 plus square root of 7, and everything, you know, in between that, just not using the endpoints. All right, very nice, guys. So let's go ahead and put that in, and I believe they're actually also asking us to graph our solution set. So parentheses, 1 minus, I guess I'm gonna have to make this smaller, square root of 7. Use the right arrow to come outside of your radical, because if you don't, you will continue typing underneath that square root symbol. So just make sure once you get that number in, use the right arrow to come outside, and then we can do comma 1 plus square root of 7, same thing, use the right arrow to come outside of it, and then close your parentheses. Alrighty, very nice. Now, can you tell me, out of the 4 graphs, which one are you going with, A, B, C, or D? Okay, let me see. I've got, okay, I got a bunch of answers and then my answers disappeared. Let's make this guy bigger. Okay, so I've got Abdul Aziz, James, Alicia, Shayna, Lowell, Oliver, Trey, and Robert. You guys are going with graph D. And then Nathan, you actually picked B for boy as your graph. Or was that a typo? Because B is going to be this guy over here. And if you remember the number line that we had drawn, we had just picked the graph in the middle, right? So that means you were not using any of the graph on the side or the interval on the side. It was just going to be, right, exactly. So that's why it's going to be graph D. Yeah, good job, guys. Very nice. So that is going to be this one. And you know, of course, we are not including the endpoint. So you can see that guy has parentheses on it. If you look at graph C, that one has brackets on it. And that's the only reason why we're not using him. So it's going to be graph D. Check, and we should be good to go. All righty. Very nice. So you should actually have a couple more examples on this. You know, this one, obviously, you want to bring the 3A to the left-hand side, get 0 on the right-hand side. Same thing here, rewrite this guy. So I'm going to let you work on this using the test point method. For the applications over here, this same example, just with a different equation or different values, is going to be part of your video lecture. I have used that exact same example here. You know, just these numbers will change based on, you know, what information they are giving you. So the equation will end up changing a little bit. So as long as you follow the steps in this example here, you will be able to do this example from your homework. So I'm going to let you guys work on that on your own. This one here, I would also like you to try at least once to work on your own. So they're telling us a rectangular playground is to be fenced off, which means they're going to be putting a fence all around that rectangular playground. And then they're saying it's going to be divided into two by another fence, which will be parallel to one side. So, you know, you can have the fence along the width, which will separate it this way, or you may even have the playground being divided equally lengthwise. But you know what? It actually doesn't make a difference, because by the time you get your calculation done, you will know how it was being, you know, separated or being divided. So I would like you to try this, and this is going to be very similar to this first word problem over here with Miss Chandra. The only difference is we were not dividing her garden into, you know, two equal parts. But if you follow this example and modify that for this one over here, I think you guys should be able to do that. So I want you to try this on your own, and we're going to be doing this last one together. So this one is talking about a farmer decides to enclose a rectangular garden using 100 feet of fencing. Okay, and then they're telling us what dimensions will maximize the area that is fenced in if the barn is used for one side of the rectangle. So basically they are saying if you have a barn on one side, so, you know, obviously that means we don't need to fence the side of the barn, and then for our rectangular garden, you're only going to be putting the fence on three sides, right? Instead of all four sides. So if you think of this as, you know, being the width of our garden, and this being the length, and they're telling us we are using 100 feet of fencing. So think about this. If I take the two widths added with the length, that should add up to 100 feet of fencing, right? So that's basically your perimeter formula. Okay, Sierra, sure, let's try with your cell phone and see if you can get a little bit better connection. Apparently, a lot of you are having trouble with Zoom and technology today. Okay, so basically, you know, this is going to be a formula, and this is the same thing you will be doing in that previous example with, you know, the garden or whatever being broken down in the middle by halfway. So take the two widths, take the length, add them together. Now, basically, the idea is you either want to get the W by itself or the length by itself, doesn't matter. In our example, the length will be easier. So to get the length by itself, what we're going to do is go ahead and subtract this 2W on both sides and move it to the right-hand side. So we'll go ahead and move this guy over here. So you should basically end up getting L equals 100 minus 2W. Okay. Now, the main question is, how are we going to maximize our area? Because they want us to, you know, create dimensions for this rectangular garden so that we can get the maximum area, you know, for whatever we are gardening in there. So ultimately, we have to use the area formula. So we're basically starting out with a modified perimeter formula, and we are going to use that to create the maximum area. Now, you should know the area of a rectangle is length times width, but instead of using length, we are actually going to substitute it with this equation right over here. So basically, you will have, instead of the length, substituted with 100 minus 2W, and then, you know, of course, we're still multiplying by this width on the outside. So you're replacing the length with the formula for the length, 100 minus 2W, and then multiply with the width. So we're still doing the area, but, you know, remember, you will create your own quadratic formula, or I keep saying formula, quadratic equation for this problem. And then when we talk about maximize or minimize, that comes from the vertex of our parabola, because remember that's where you have the maximum or the minimum value from the k coordinate of our vertex. You get the maximum or the minimum value. So that's actually where we are headed when they talk about maximizing the area over here. So what we are trying to achieve is get our quadratic equation. Once we have the quadratic equation, we can find the vertex. Once we find the vertex, we can find what the maximum or minimum value for that parabola is going to be. So your next step here is going to be, oops, always forget that. The next step is going to be, we're going to take this W and distribute it inside the parentheses. So that will end up giving us 100W minus 2W squared. So you can think of W as being our X variable and A as being our Y variable. So if this is going to be our quadratic equation, what do you think the vertex of our parabola is going to be? 0, 100? Okay, let's verify that. So remember, when our equation was given in the standard form, we used the formula negative b over 2a. You are still going to use that. So negative b over 2a. A is always from the square term. B is always from the middle term. So what's our b value over here? Very nice. Yes, your b value is coming from that middle term, which is the 100W. So b is going to be positive 100. And then what's our a? Very nice, Nathan. Yeah, because that's going to be the coefficient from our W squared. So that's going to be the negative 2. So basically, let's see, what do we end up with? Negative 100 on the numerator, negative 4 on the denominator, and what's that when we simplify? So Abdulaziz, you can see how your ordered pair does not work out then in this case, right? Very nice. So that gives us positive 25. So remember, that's going to be our X coordinate for the vertex. And now we need to find our Y coordinate, which we're using the variable A for that. So basically put this back into your equation where X equals 25, or W in our case. So what would that be? 100 times 25 minus 2 times 25 squared. So what do you think this answer will come out to be? So 100 times 25 minus 2 times 25 squared. When you simplify that, what do you get? 0. Okay, because I did not get that. So let's take a look at this. 100 times 25 would of course become 2500 minus, you would of course have to do 25 squared first, which should give us 625. And then when you multiply that by 2, looks like that comes out to be 1250. And then what's 2500 minus 1250? So Abdulaziz, you had a bunch of different answers here, but yeah, it should be 1250 by the time you clean this entire thing up. So your X value for the vertex is 25. The Y value is 1250. And you should notice, since our A value was negative 2, if this was a parabola, it would definitely be a parabola opening downwards. and then our maximum value, or the vertex and the maximum value would, of course, coincide at this point over here. So this is basically telling us that to get the maximum area for our, okay, I lost my train of thought. Our area needs to be 12,050 square feet, right? Because that's the A value we came up with. And so that means our dimension is going to be W, your width has to be 25. So what do you think the length will then need to be? If you calculate backwards, what will the length of this rectangle need to be? And for that, you will go back, of course, to this perimeter formula that we started out with, that we rewrote. James, you're coming up with 50. Okay, so let's do a quick verification on that. Okay, and looks like Abdul Aziz, Nathan, you guys also had the same thing. So let's do that here. Length is 100 minus 2W. And if we are saying that the width is going to be 25, of course, 2 times 25 will become 50, and 50 from 100 will give you 50. So we're basically saying the length should be 50 feet and the width should be 25 feet. All right, let's check that. Put it into our, so let's see, the larger dimension is of course the length, which will be 50, and then you have to choose your measurement, so it will be a single length, so that's feet, none of the square calculations, and then shorter one was the width at 25, and again this is also going to be feet. And let's check that answer. There we go. So each of these questions are going to be a little bit different. But if you follow along this example, then the one before this with the garden example with the 5 sides, you should be able to use that same idea. Now for the archer example, I definitely, if you have not seen the video lecture, go see the video lecture, because I explain in detail how to do that archer example. So questions on this one here, guys? No questions? Alrighty, so this basically ends our section on 3.1. Now this is our third larger chapter. This also has 5 sections. So we're done with 3.1. Of course, we have 4 more sections, and then we'll take the exam. So again, I'm not sure what's going to happen with the exam date, but that's kind of where we are headed with this chapter. Okay, so if you guys don't have any questions, have a great day, guys. Be careful, and I will see you on Wednesday afternoon. Be safe, everyone. Take care. Bye-bye. Bye, guys.